Soon. All right, ladies and gentlemen, today's video is about calculating the slope. We've done a lot of talking about what slope is and a lot of investigating slope through some of the graphing that we've done. But let's just review briefly. Slope describes the steepness of a graph. So the rate at which it increases or honestly decreases. Okay, so a graph can go up really fast, it can go up kind of fast, it can go down really fast, etc. All of those different things are the slope, how steep it is. Oh, hang on. Put your objective in there, guys. I got a little ahead of myself. Your objective is that I can calculate slope using a graph, two different forms of a linear function, and ordered pairs. Those ordered pairs might be in a list or a table. Okay? So take a moment to write down this objective. Make sure you put the heading and the date and the page number, all that good stuff. And write down this little note to yourself to remember that slope describes the steepness of a graph or the rate at which it increases. Put a little circle around it too, because that's really important that we remember. Okay? When you're ready, let's go ahead and move on. We're first going to look at a graph, okay? And really what we're asking ourselves when we are talking about slope is how fast does it decrease or increase, but really, how does it change? Write that down. This should be on the same page, just the bottom half of that page. How does it change? And mathematicians, so that everybody's kind of on the same page with this kind of thing, we like to describe how it changes up and down. And I'll show you what that means in just a second. How it changes up and down, and then, second, how it changes left to right. So how it changes up and down and how it changes left to right. Now, what exactly are we looking for how the graph is going to change? When you're looking at a graph, first thing you want to do is pick a point on this line that hits right at the intersection of your grid paper. So for example, this point right here is right at the intersection of some of my grid paper. And then another one is, there's one right there, and one right there. Okay, so I have them every couple of places. I have a spot where my line hits the grid of my paper. So what we need to describe is how it goes from one spot here to the next spot here. And remember, we're going to describe the up and down movement first. So to get from this point on the graph to this point on the graph, where do I have to move in the up and down direction? Hopefully you answered that you have to move up 2. Okay, so we have gone up on this graph 2 places. All right, now let's go ahead and erase that, and using those same 2 points here to here, we need to ask ourselves, how far do we have to go in the left to right direction? We have to go from here to this point right here. So we have to go to the right 1. Remember that the right-hand side of the graph is my positive and the left-hand side is my negative. That's important here. So the slope of this graph is going to be written, it goes up 2 and over 1. Mathematicians don't like to use that many words in math, so they actually take this and turn it into a ratio or a fraction. For every 2 I go up my graph, I have to go over 1. So my slope here is 2 over 1, or simply 2. So if I were to write my equation in slope-intercept form, it would be y equals 2, which is the slope, times x, and then plus some b, some intersection where my graph hits the y-axis. Okay, this too is the slope. Let's look at another example over here. I can pick any 2 points on this graph to calculate the slope, and I should end up with the same answer. So I'm just going to pick some. I will choose this point right here, and I will choose this point right here. And I chose those points because they're on an intersection of my grid lines, which makes my life a little bit easier to count where it moves. Remember, we look for the up and down first. So where does it move up and down? To get from this point to this point, I need to go down one space. You with me so far? And then to move left to right, we have to go from here to here. So that's 1, 2, 3. We go over to the right 3. I want you to remember that on an XY grid like this, on the y-axis, positive is up, negative is down. So if I go down 1, that's going to be -1, describes my up and down motion. And then over 3, that's just going to leave me -1/3 is our slope. And mathematicians like to use the variable m for slope. You'll see that a lot. You saw it in the standard form of the slope-intercept, sorry, not standard form. You saw that in slope-intercept form, y equals mx plus b. And m is the slope. So -1/3 is the slope for this problem. All right, make sure you get all that down, a little sketch of the graph, a little drawing of how it moves, and then we can look at how to find slope when we are given an equation. Okay, so let's say, this will be on the top of page 49, November 19th, by the way, and I want you to take the top half of your page and divide it in half. Okay, don't put that line all the way down, just to the halfway point of your page. And on the left-hand side, I want you to write from slope-intercept form. And on the right-hand side, I want you to write from standard form. This is finding slope still. So, last night's homework was about switching back and forth between slope-intercept form and standard form. So now let's look at an example of how to find the slope in each of these forms. So a slope-intercept form of an equation. Let's just say we have y equals 6x plus 2, and then our standard form equation, it's not going to be an equivalent equation, it's a different one. Let's say it's 3x plus 2y equals 8. Okay? In the slope-intercept form, finding slope is really, really easy. It's the coefficient of x. That's all. Remember that slope-intercept form is y equals mx plus b, and m is the slope. So if we have an equation given to us in slope-intercept form, finding the slope of the equation is extremely easy. If you have an equation in standard form, you have a couple choices. You can either change it to slope-intercept form, which would then make it very easy to find the slope. So that's one choice. Your second choice, though, is to use this little formula that essentially tells you what the coefficient of x would be if you were going to change this into slope-intercept form, but without actually doing all that work. So the little formula we have is -a over b. And you can see how that might work if we take the standard form of an equation, ax plus by equals c. Well, if we wanted to change that into slope-intercept form, we would subtract ax, giving us by equals -ax plus c. X terms go first, remember. And then we would have to divide both sides by b, everything up here by b, canceling those, and you get y equals -a over b x plus c over b. So in standard form, this little kind of shortcut equation essentially tells you what the coefficient of your x would be if you changed it into slope-intercept form. And that coefficient of x tells us what the slope is. So if we give this example, 3x plus 2y equals 8, and we are looking to find -a over b, well, a is the coefficient of our x term, which in this case would be 3, and b is the coefficient of our y term, which in this case is 2. So if we want to do -a over b, it would end up being -3 over our b is 2. And that is going to be our slope for this equation. So you can either turn it into slope-intercept form and find what that coefficient is, or you can simply say, I'm going to use this shortcut. I memorized it, so I'm going to use it, and then you can use it that way to find the slope. Okay, I'm going to go ahead and skip from a table right now. We'll catch up to that in class tomorrow because I don't want to make this video too long for you. And for your reflection, this first problem is finding the slope on a graph. And for the second problem, I want you to find the slope of the following equation. Negative 4x plus 6y equals 12. Okay? Slope of the graph and slope of this equation. Thanks, guys. Have a good one. I'll see you tomorrow.